Okay, hello everyone. I am Ajay, and today we are going to solve the problem of hot rolling with two stages. So this is the interface of Abaqus. Now we'll start with the part module. So we have selected here part module. Now we'll make each part one after another. So we'll create stock, and you can see we have created stock of the required dimension which is given in the input file. So after creating a stock, we'll create role 1. You can see here, and the dimensions are given in the input file. So we'll create role 2. Then after that, we'll create descaler. So yeah, after creating all the parts, we'll proceed toward property module. So in the property module, we'll create material for all the parts which we have created. You can see here in the material manager we have created two material. One is stock material, second one is roller material. So in the stock material, we have given all the properties which were given in the input file. You can see we have given density, conductivity as 30. Actually, we are taking unit like the unit of force is Newton, the unit of distance is in mm, and the unit of time is in second. So you can see the conductivity we have taken as 30, density is this, and we have given plastic property as temperature dependent. So we have given Young modulus and Poisson ratio with the variation in temperature, and after that we have given expansion coefficient and inelastic heat fraction. We have given proper plastic properties also. And last one is specific heat. So after creating stock material, we will create a roller material. So we have given properties to roll. We have given conductivity, density, elastic properties, and specific heat. So after creating material, we will create section. We have created three sections. One is roll section, second one is descaler section, and another one is stock section. After creating this section, we will assign whatever property we have created to the parts. So we'll assign properties individually. We'll go to stock, then we'll create. No, actually we have created sections, so we'll directly assign the property of the created material to the parts. So after assigning properties, we'll go to the assembly. Now you can see we have, so in the assembly module, we'll create instance. Instance is actually the copy of the original parts we have created. And yeah, after assembling all the parts according to the required dimension, which is given in the input file, we'll proceed to step module. Now in the step module, so in the step module, we'll will create steps. So at the initial step, the stock will be at this point, and in the step one, the stock will approach toward descaler and then towards roller one. And in the step two, rolling will take place. And in the step three, again the stock will proceed toward the descaler two and roller two. And after that, in step four, again rolling of second stage will take place. So actually we need to give the step time. So we'll give, you can see here, I have given the time period for step 1 is 13.76, and for rolling we have given the time period of 1.3, and for step 3 we have given time period of 4.27, and for step 4 we have given time period of 2. Okay, so after completing the step module, we'll proceed toward interaction module, and in the interaction module will provide the properties, how the interaction between the stock and descaler is taking place, and how interaction between the stock and the roller taking place. So you can see we have given roller convection, roller convection 2 for second roller, and we have given roller radiation. You can see roller stock interaction, stock and the interaction between stock and descaler. So we have given this all interactions, and here we have chosen the penalty contact also. So in this way, we will give the interaction properties, and after giving the interaction property, we'll go to the load module. In the load module, actually we need to provide the boundary condition to all the parts, and to provide the boundary condition, we need to create reference points. You can see we have created reference point for the roller at the center, and for the descaler, we have created reference point at the mid of the top surface. And similarly, we have created a reference point for the stock also. So this is my stock. Okay. Now we'll go to the boundary condition manager. Here you can see we have given this all boundary conditions. We have encasted our descaler, and we have given translation to roller as 0 in both direction, and we have given roller velocity as the actually we have given angular velocity of the roll as 1.82, and this is the stock translation velocity we have given as 1000. So yeah, in this way we'll give the boundary condition to all the parts, and after giving the boundary condition, we'll go to the mesh module. In the mesh module, actually we have two options. One is assembly and second one is part. So in the parts, we'll go to the each part, and then after that we'll create mesh. So in the mesh module, we'll go to the mesh control, and then element type we'll select as quad and quadrilateral type, and then technique as structured. Now we'll go to the element type. Here we need to select the part. So here we have selected family type as coupled temperature displacement and element library as explicit. So in this way we'll choose mesh control and mesh element type. And after that we'll go to the seed edges, and after giving the seed we'll create mesh. So in this manner we'll create mesh for roller also and for the descaler. So yeah, in this way we can create mesh for all the parts. And after creating mesh, the last module which we, we need to do is we need to submit a job. So you can see this is job manager. Here we'll create a new job. We'll give a name, and then yeah, after continue, we can submit our job. And after submitting, we can see the results from you can see I have already submitted. So let me show you the result of one submitted job. Here is the option. So now we'll go to the visualization, then plot contours. So you can see the result of our hot rolling problem. I can show you step by step. So how rolling is taking place, you can see from this result. So in this way, we'll solve our hot rolling problem. And thank you.